Hello, Dr. Colton. That is Zach's lunchbox. We are Zach's lunchbox, and this is Zach.
Hey.
My name is Porter, and we wanted to talk to you a little bit about our robot today. So as you know, our goal is to get this rover to be able to collect samples and transmit data. But our goal with Mars is eventually one day to get humans there. So we actually transformed this into a snack providing robot as well to feed those humans one day. But let's talk about our real mission. So with our code, one way that we wanted to format it to make it really robust and usable for any member of our team is we used a 3-file project system. So we had a header file with all of our functions defined. We had our main function that would actually run the functions for our mission. And then we had a functions file where we could create lots of different functions and then integrate them together. This really made it very easy for us to all work on the code. We made sure to comment things very well and make it very clean and usable. One of the things that we would change going forward in the future is we had to end up using an 8 post scaler with an 8 megahertz oscillator. We're feeling that our robot might be slowed down a little bit by this post scaler, so we would try and use a timer to control a PWM pin in the future. But now I'll pass you on to my colleague, Adam.
So an important design decision with this robot was using a PCB. As a full team of mechanical engineers, it was a big challenge. One really unique thing about it is that we have 2 buck converters that step the voltage down from 12 volts to 5.5 and 3.3. Another really important design decision was to make this thing adaptable. As you see, we have a 5 volt rail and a 3.3 volt rail, so we can change things as needed. One of the biggest lessons that we learned from doing this was that we probably hold a more robust team design review of the PCB. We learned that direct current does not flow through a capacitor, which was a really big problem at first. But we got it to work and it was really good for us. So I'm gonna pass you on to my friend, Ubi.
Thanks, Adam. One thing you might notice all around here is that we have these 3D printed mounts that we use not only for the PCB and these Polulu boards, but also for everything on the front here with our ball collection. And we like that because it keeps everything in a nice tidy place. It makes it easy to secure things in place. But we did realize that these were not as strong as we needed them to be as we set this thing down. In fact, Adam set this down and we broke this mount straight in half. And so we added a rib to give this a little bit more strength. We also broke this guy, hence round 2. But one of the main things is our base. We started out too large because we thought we needed all this room to put everything. But we found our line following was not very good and we couldn't get through the canyon like we expected to. So we shrunk it down actually twice. This is our 3rd revision of the board to make it so that it will fit through everywhere it needs to and be more maneuverable. Over to you, Zach.
Finally, we originally intended to use a relay to split our PWM between our servos. We ended up not having to do that actually, which was really nice because we discovered that our servos did not interfere with each other, so we could control them at the same time without any problems. Finally, one of the most important changes we made was our QRD mount. It was originally in line with the effective axle, but that made our line falling really struggle. So we moved our QRDs out about 1.5 inches, and that decreased our effective turn radius, maximizing and increasing our line following to make it the best it could be. And that is all we have. Thank you.